Now let's try a second example. Let's have a look at this. We've got 4 grams of copper 2 oxide and we've got 200 ml of 0.6 molar hydrochloric acid. Now we've got 2 sets of information. So immediately the alarm bells go off. Ding, 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 ding. It's a limiting reagent question. Now the first part of the question asks us to write a balanced ionic equation. So we've got copper oxide, which is a base, and we're adding it to hydrochloric acid, which is an acid, so it's acid plus base gives salt plus water. Now we're going to have to do part B, find the concentration of the hydrogen, copper 2 and chloride ions. Now in order to do this, we need to start at the beginning and find out which of our reagents is the limiting reagent. So we're going to start by finding the moles. So the number of moles of copper oxide is equal to mass over formula mass, which is equal to 4 divided by 79.55, and this comes out to 0.05028 moles. Now I like to store this in my calculator so that I can use it later. Now the number of moles of hydrochloric is equal to CV, which is 0.6 times 0.2, which equals 0.12 moles. This means the number of moles of hydrogen ions will be the same, and the number of moles of chloride ions will also be the same. Now the next part is I like to use the pick and choose method in order to find out the limiting reagent. So I'm going to try that. I'm going to go 1 mole of copper oxide reacts with 2 moles of hydrogen ions. So if I use 0.05028 moles of copper oxide, it will react with X moles of hydrogen ions. So from there I can find that X would equal 0.05028 times 2, which means that I would need 0.10056 moles. Now at this point in time I'm going to ask a question, and the question is, do I actually have 0.10056 moles of hydrogen ions? And if I go back here and have a look at what I've actually got 0.12, so I've got plenty. So that means the limiting reagent is the copper oxide. Now we can get on and find the concentration of all the ions. So the volume hasn't changed, so the volume is still 200 ml, which is 0.2 of a litre. So this means that the concentration of the chloride ions is still 0.600 molar. Now let's find the concentration of the copper ions. We know that 1 mole of copper oxide produces 1 mole of copper ions. This means that if I have 0.05028 moles, I'm going to end up with X moles of copper ions. So the number of moles of copper ions is going to be equal to 0.05028 moles. So the concentration then of copper ions is equal to number of moles divided by volume, which is 0.05028 divided by 0.2, which is equal to 0.251 molar. Now as we've got 3 significant figures here, 3 significant figures here and 3 significant figures here, this needs to be answered to 3 significant figures as well. Now we're going to do the harder part. We're going to find the concentration of the hydrogen ions. So we know that 1 mole of copper oxide requires 2 moles of hydrogen ions. So if we used 0.05028 moles, this is going to require X moles of hydrogen ions, and the number of moles of hydrogen ions used will equal 0.05028 times 2, which is 0.10056 moles. Now you notice that way back in my pick and choose method I already calculated that, so I could have just used the previous answer. Now let's try and find the number of moles of hydrogen ions left over. So in excess, which equals the number of moles of hydrogen ions from the start, minus the number of moles of hydrogen ions used. This means that you're going to start with 0.12 moles minus 0.10056, and this comes out to 0.01943 moles. So the concentration of the hydrogen ions is equal to number of moles over volume, which is 0.01943 divided by a volume of 0.2, and this comes out to be 0.0972 molars. Now let's do part C. Part C asks us to find the pH, and remember a pH is the power of the hydrogen ion concentration. So pH equals negative log of hydrogen ion concentration. So in this case it will be negative log of 0.0972. So that will come out to 1.01 as a pH. Remember, 3 significant figures.